Hello and welcome to this video lesson. In this video lesson, we'll be talking about surface area and volume of a cone. Let's talk about the surface area first. Here we have a cone, and the cone is kind of consisted of two sections. One is the base area, which is this region over here, which is just the circular region, and we have the lateral section over here, which is pretty much the rest of the cone. So we got the base and we got the lateral section. In terms of terminology, the height is from the top point all the way to the center of the circle or the center of the base. The radius is just the radius of the circle. And S stands for slanted height, and that's the height that's slanted. So this actually makes a right angle triangle. And the slanted height is the hypotenuse of this triangle. When we're looking at the surface area of a cone, we're looking at two regions again, the base and the lateral section. So we call this section the lateral area, and this section would be the base area. The base basically has a shape of a circle with radius of r, and a circle with radius of r simply has an area. So area of the base is equal to pi r squared, and that's simply whenever you have a circle with radius r, its area is pi r squared. So that's the area of the base. Now, the more challenging conceptual idea is how do we figure out the area of the lateral section? And if you look, we can see that the bottom of this, the circumference of this circle is this region over here. So if we were to if we were to cut our cone from, let's say, this line and start opening it up like this. So here we're opening up our cone until we kind of get the net area, which looks like this. You can see that it looks kind of like a triangle. However, this section over here is it's pretty much an arc. And this arc length over here is equivalent to 2 pi r. So let's see why this is. So looking at the base over here, this is 2 pi r, meaning this whole section is 2 pi r, meaning this whole section is 2 pi r. And as we unfold this section is 2 pi r, unfolded, this section is 2 pi r, and when we fully unfold the shape, or just the lateral section, this whole section should be equivalent to 2 pi r. And I made a small mistake in this shape over here, so I'm just going to erase this and replace it by 4 sectors instead of 5. So cut this in half, cut it in half again, and cut it in half again. And now we have 4 sectors. So what we've done is something really interesting. We've taken our lateral area and we've divided it into 4 different sectors of equal area. Now, this is interesting because you can actually make this into infinitely many sections, but here we've just, for illustration purposes, we've only divided it into 4 different sectors. And once you have the sectors, what you can actually do is you can take this first sector, place it in this direction, take the second sector, flip it and put it in this direction, the third one, put it down here, the fourth one, and take the fourth one and put it down here. And by doing that, this length over here, which is the slanted height, actually does not change, so you still have the slanted height over here. But at 2 pi r, you can see that half of my shapes I have placed in this direction, and half of them I have placed in the opposite direction, meaning if this whole length is 2 pi r, that means that this length is pi r and this length is also pi r. Now, if I start dividing this into more and more regions, so I will actually add a little bit more regions over here and draw it out. And I will now have side like this. And the first one is like this. And I have 1, 2, 3, 4, 5, 6, 7, 8. So one region like this. And then one region like this. And one region like this, one region like this, one region like this, 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 and finally this. And you can see that as and I'm going to draw this as a solid line like this. And you can see as I just divided this into more sectors, I got a shape which is a little bit less slanted. So this angle is actually starting to become 90 degrees. So if I start dividing my shape into more, and more regions, I will start actually making a shape which will be a rectangle. And in this rectangle, and this is, again, this is only 8 sectors. If I had divided into more, it would look much more like a rectangle. Has slant height, or this side of S, and this side will still be pi r. And now I'm not drawing each one to scale, so things will look slightly different, but you can see that this length over here, pi r, this length over here is S. And if I were to take the area of this shape over here, which is actually approaching a shape of a rectangle, I would actually have to multiply length times width, or let's say this is the length and this is width. So the area of this shape over here, or the area of the lateral section, and I'm saying area of the lateral section because this area is pretty much this one over here. All I've done is take the sectors and place them in opposite directions to make this beautiful rectangle. So I got lateral area of a rectangle is length times width, so it's S times pi r, or width times length, so it's pi r times S. So pi r times S. And to get the area of a whole cone, what I have to do is take the area of the base, which is pi r squared, and add it to the area of this section over here, which is the lateral section. So the total area, or the total surface area of a cone, is equal to area of the base plus area of, or lateral area, which is equal to pi r squared for the area of the base and pi r s for the area of the, or lateral area. And sometimes lateral area, we write it as LA. So if you ever see LA, it means the lateral surface area of a cone or other shapes that have a lateral surface. Now, let's talk about the volume of a cone. So a cone is shaped like this. So if we actually take a cylinder which has radius of r and height of h, and actually have a cone which has the same height and the same radius, and let's say we fill this with a liquid and we start pouring this liquid into this cylinder. And we will actually notice that if we do this, we will get water being filled out about 1/3 of, or 1/3 of the cylinder actually gets filled up. So this actually, when we fill it by 1, we get 1/3 of our height here, or 1/3 of our volume being filled up. And if that's the case, if every time we pour water or a liquid into the cone and start pouring it into a cylinder which has the same radius and same height, 1/3 gets filled up. That means after 3 times we will fill this whole region. And there are many videos online that actually illustrate this, so if you folks want to look that up, you can definitely do so, and I know there's at least 1 or 2 really good videos that cover that. And we can see that volume of cylinder is equal to pi r squared h, and volume of a cone is equal to 1/3 of volume of the cylinder, meaning that volume of cone is equal to 1/3 pi r squared h, and we can box this as one of the equations that we will be using for the rest of our course. And alternative way of writing this, which is the exact same thing, is just pi r squared h over 3. So these two are pretty much the exact same thing, just represented in different forms. Our first example today asks us to determine the volume and surface area of the following shape. In this case, we have a cone. Our cone has slanted height of 13, and it's got a radius of 5. And we don't know what the height is, and we're trying to find 2 things. We're trying to find the surface area, and we're trying to find the volume. So for the surface area is equal to surface area of the base. Actually, I'm just going to write it as area of the base. Area of base plus area of lateral surface, or you can write it as LA. And area of the base is pi r squared, and the lateral area in this case is equal to pi rs. We have all the values that we need, so in this case, the values that we need is r, which is 5, s, which is 13, and that's all we really need in our equation. So pi, instead of r, I am going to plug in 5 squared plus pi. Instead of r, I'm going to replace it by 5. S, I am going to replace it by 13. And we can keep going with exact numbers here. 5 squared pi. 5 squared is actually 25 pi. And pi times 5 times 13. 5 times 13 is 65 pi. And if I add these up, I should get 90 pi as my final answer. And in terms of units, I have meters. Meters times meters is simply meters squared. So my units for this is meters squared, meaning that my surface area is 90 pi meter squared. Now, in this case, we have left our final answer as an exact value, meaning that there's no rounding done at all. So our final answer is 90 multiplied by pi. And the way we added this pi here is kind of like a like term. So 25 apple pies plus 65 apple pies means that you're adding 65 plus 25 apple pies, which gives you 90 pies, and this is as exact as it can get. But let's try to see what happens if we plug this into our calculator. What value will we get from our calculators? So having plugged this into the calculator, I get a value of, I'm going to write it as approximately 282.743 meters squared. So you can right away actually plug everything into your calculator and actually get an answer here. And when you do, you will see that your answer will be given in many number of decimal places or significant figures. And we don't want to write everything down. So this actually will probably continue on for a really long time because we're multiplying it by pi, and pi has infinite number of decimal places. So this will have infinite number of decimal places, and we don't want to write all the digits down. So in this case, I want to write, usually every course and every teacher will ask you to do things differently. Usually when I teach it, I ask students to leave their final answer, if it's rounded, to three significant figures. In this case, I have 6 significant figures. This is my most significant figure. This is my second most significant figure. This is my third significant figure. So I want to write my answer to 3 significant figures. So I will just highlight these 3 values. And when I'm writing it in 3 significant figures, you can see that I have 282.7. And since 7 is higher than 5, I have to go and round this 2 up to a 3. So my final answer rounded is 283 meters squared. If I had left this as just 282, it would not actually be a good answer, or good, well, it's completely a wrong rounding, because 282.7 is closer to 283 compared to 282. So we do want to make sure that we write our answer in proper number of significant figures, and that depends on your teacher. I ask my students for 3 significant or sig figs. I am going to box this answer. The other thing that you need to pay attention to, and sometimes it's just much better form to, if you are estimating an answer or rounding things, make sure you use an estimation sign. An estimation can be written in many different ways, and again, there's many different forms and representation. This is one way, this is the other. I am going to be using this mostly in my videos, but you may see this one as well here or there. Alright, so now we have found our surface area, but we haven't finished answering the question. The question also asks for the volume. So first thing I'm going to do is actually write the equation of the volume, which is 1 over 3 pi r squared times h. Now, in terms of my variables, I have r as 5, that's my radius. I have 1 over 3, and I can just use that. I have pi. Now, r squared I have. H I don't have. I don't have that value, so I have to find h before doing anything else. So h over here, I can see that this little part over here has formed a right angle triangle. So I'm just going to draw that out over here. So this is a right angle triangle. My radius is 5. My hypotenuse here is 13, and I don't know what h is, so that's what I'm trying to find. And using Pythagorean Theorem, I can just say that the hypotenuse squared, which is 13 squared, is equal to the 2 side squares, the sum of the 2 sides squared. So h squared plus 5 squared. And if I solve for h, I can subtract 5 squared from both sides, and I get 13 squared minus 5 squared is equal to h squared. 13 squared is 169. 5 squared is 25, and that is equal to h squared. So 169 minus 25 is 144, and that is equal to h squared. So h, take the square root of both sides, and you get h is equal to plus or minus 12, and plus or minus square root of 144. Just thinking one step ahead here. which is h is equal to plus or minus 12. But since sides cannot be a negative value, so h has to be larger than 0, therefore h is only positive 12 and not negative 12. Fantastic. So now for my volume equation, I have everything that I need. I have R, I have H, and I can just plug it into my equation. So let's do that over here. Volume is equal to 1 over 3 pi. My R value is 5. Put that inside brackets. Multiplied by my H value, which is 12. And I'm going to write the answer in exact form first. And this over here was also exact, so I didn't actually need to leave it in decimal. I didn't need to round it. I just left it as very nice value of 12. And here I have 1 over 3. So 1 over 3, I'm just going to show you folks here. I have 1 over 3, so that's 1 divided by 3. That means this whole thing is being divided by 3. And here I have 12, which is in the numerator, and I have 3, which is in the denominator. So I can actually simplify this a little bit right away. I can divide 12 by 3, and I get 1 and 4 over here. And then when I multiply things out, I get pi times 5 squared times 4, which is pi times 25 times 4. Oh, this is fantastic. And 4 times 25 is just 100 pi, which is my exact answer in this case. And since it's volume, that means you're multiplying a side times another side times another side. So you're meters times meters times meters, which gives me meters cubed as my final answer over here. And this is an exact form of the answer. If I wanted a rounded answer, I can just plug this first line over here into my calculator right away. So 1 over 3 times pi times 5 squared times 12. And if I did that, I would have gotten an approximate answer of 314.159. And there's more digits to this. And I will leave my answer in 3 significant figures here. So I will highlight my first 3 significant figures. Look at the digit right after. This is a 1, which is smaller than a 5, meaning that I don't have to round up the 314. So my final answer in this case would be 300. I'm just going to write it in purple. 314 meters cubed as an estimation of my final answer. And in my course, you can actually leave your answer as an exact form or a rounded value. However, you must, if unless the question actually states to write your answer in exact form, you have the choice of actually leaving it here and not going through this calculation over here. All right, this question over here says that provided that the LA here stands for the lateral surface area of a cone is 40 pi centimeters squared and its radius is 5 centimeters, calculate the total surface area and volume of the cone. What I'm going to do first is actually write down whatever information we have. So here we know that the lateral area surface, or the area of the lateral surface, is equal to 40 pi, and we know that the radius is equal to 5 centimeters. And this is squared, this is centimeter. And we're looking at two things. We're looking at this total surface area, and we are looking for the volume of the cone. So let's do surface area first. So the surface area simply equals to the area of the lateral surface plus the area of the base. So we have the lateral surface area as 40 pi, so we don't really have to calculate that part. 40 pi. And the area of the base we don't have, but we have an equation for it, and the equation is pi r squared. So pi r squared, we have the radius. The radius is given to us as 5. So we can write that as 40 pi plus pi times 5 squared. And I'm just going to calculate this as an exact value first. So 4 pi plus 25 pi. And if you have 40 pies and you add another 25 apple pies, that's going to be a lot of apple pies, but you are going to have a total of 65 pies in total. And my unit for it is centimeters squared, and our surface area is 65 pi centimeters squared as an exact value. And we can actually plug this into our calculator as well. And as we do that, we should get 204.204. I'm going to leave our answer in 3 significant figures. The first 3 significant figures are these, and then I have 0.2. 2 is smaller than 5, so I don't actually have to round this digit up. So my final answer, right in purple, is 204, or approximately 204 centimeters squared. So you can leave your answer as this, or you can leave it as an exact value of 65 pi. So we have answered the first part of the question, which was the surface area, which is awesome. Now we got to answer for the volume. So I'm just going to write that here. Volume is equal to, I'm just going to write it in the other form, pi RH over 3. Again, it doesn't matter which way you write it. All the forms are actually, in this case, the same. And this is pi r squared h over 3, actually. Now, looking at for the informations that I have and don't have, I have the radius. I don't have the height, so I can't really do anything yet. So usually when I don't have the height, the first thing I do is I draw a right angle triangle. In my right angle triangle for a cone, I have radius, I have height, and I have the slanted height. So usually what I do is I use Pythagorean Theorem to find h using r and s. So I do have r is equal to 5 in my case, but unfortunately I don't even have s, which is the slanted height, so I have to figure that out as well. Now, how do I find that? So in terms of the information I was given originally, I have the lateral surface area and I have r. So the lateral area surface is the only other information that I can actually use. And so let's write area lateral surface, or area of LA, or just LA would also work in this case, lateral area. And this, in terms of equation, I do have an equation for this, and the equation for this is pi rs. And I know that the lateral area is 40 pi, so I can write that as 40 pi is equal to pi, and this is pi. R value is 5, and I don't have s, so that's what I'm trying to find. And you can see that my s and 5s are very similar, so it's going to be a little bit challenging to distinguish between them, but I'll try to write it so it looks slightly different. So here I have one equation and I have one unknown, and that unknown is s. And my right-hand side of the equation, s is being multiplied by 5 and pi. So in order to isolate for s, I'm going to divide both sides by 5 pi. By doing that, I'm going to do that in blue so you can see it. I'm going to divide this side by 5 pi, and I'm going to divide this side by 5 pi. pi's cancel, 5's cancel on the right hand side, and on the left hand side is pi cancel, and 40 divided by 5 is 8 over 1, meaning that my final value for my slanted height is 8 over 1, or simply just 8 centimeters. So now I have my slanted height, so I have this value over here, which is 8. So I can go ahead and use Pythagorean theorem. So using Pythagorean theorem, I can say that 8 squared, 8 being my hypotenuse, is equal to h squared plus 5 squared, which is the sum of my two other sides. So 8 squared is 64, is equal to h squared plus 5 squared, which is 25. I'm going to isolate for h by subtracting both sides by 25. So I get 39 is equal to h squared, and I will just write it as h squared is equal to 39. And to find h, I would have to square root both sides, and I get h is equal to plus or minus square root of 39. And since h is a side and it always has to be a positive value, then h simply is square root of 39. Or if I plug it into my calculator, I will get h is equal to approximately 6.245, so actually 6.244, actually write it down, 244, so 3 sig figs, the 4 after my 4 is smaller than 5, so 6.42 centimeters is an approximate value. So finally, I have my h value, so I can go back to my original equation here. So volume is equal to pi. My r value is 5 squared. My h value is square root of 39, or you can use 6.24. When you're using this value, though, you have to use whatever you get in your calculator with as many significant digits as possible, because if you round this value over here, then you will not get, you might not get the exact answer that you need for the final stage. And the reason for that is because you're rounding, and if you multiply two rounded values, you're propagating your errors each time, and that might cause an issue. So I'm just going to erase this. So once I can do this on my calculator or get an exact value. So the exact value for this would be 25, because 5 squared is 25, root 39, because that cannot be simplified any further, pi over 3. And really it's a little bit, it's writing as an exact form is okay, but it's a little bit confusing in this case, so I'm actually going to, in this case I kind of prefer to see the estimated value. So I'm going to plug this into my calculator, and I will get 163.494, and I want 3 significant figures, so my first 3 are here. And since the 4th significant figure here is smaller than 5, then I don't have to round this 3 over here. So my final answer then will be 163 centimeters cubed, and I will box my answer.